Okay, so right. Last day we discussed about substitution rule, and when you apply substitution rule, you can create that form, the form that I mentioned last day, to choose an appropriate suitable substitution. Right? So I think with that understanding, you should be able to complete these two, 4 and 5, these two questions, because the same idea, we can express these integrals like this: sine natural log of x times 1 over x. I would like to express that one as the derivative of natural log of x. So after creating this form, I think you can easily understand this entire thing, this part. What do you think about this? This is basically the derivative of minus cosine natural log of x. If you apply differentiation, basically the chain rule, to differentiate this function, you will get this. Don't need to compute antiderivative like that. Don't need to write your answer straight away. We can use substitution, but the idea is that chain rule, we apply reverse chain rule in a way, because we need the original function that we applied chain rule, that is cosine natural log of x. After applying chain rule, after differentiating that function, you will get this, basically this function. So the antiderivative of that function is nothing but this function, like that. That's the idea. So the substitution is again natural log of x. Similarly, for the fifth question, same thing, same idea. I think if you observe carefully, now you can understand the importance of this x. That's quite helpful. Otherwise, it's quite difficult, actually. Integrate natural log of x. That is like this. Then again, u equals natural log of x. By observing this, now you should be able to write the answer actually. But don't need to do that, because basically we just need to integrate something like this, square root of x dx, a situation like this. But instead of x, we have natural log of x. So that's why we use u equals natural log of x as our substitution to create a form like. Then we can integrate. I think we get something like this: natural log of x to the power of half plus 1 over half plus 1 plus c. Don't need to write your answer straight away. You can use substitution and complete. You will get this answer. Right. So that's the idea. Always focus on this form. Try to create this form whenever possible. This form. Right. Then now I think we can move forward with few different problems now. These problems we discussed. Now, few different problems. This one also we just discussed that. So the sixth one, the same idea, because the inner function is natural log of x. But if we consider a case like this, natural log of x squared times x dx, now you won't be able to use natural log of x squared as your substitution, because that's not the inner function. Can you understand that? if we pick this part separately, you can understand, I think you can understand, there are two functions here. X to x squared, that's the inner function. Then x squared to natural log of x squared, that's the outer function. Right? In this case, actually, the appropriate substitution should be u equals x squared, the inner function. Right? So that be careful when you are using this method. Always try to compute, try to identify the inner function, right? And similarly, so same idea, I think you can complete these two also, very similar, right? So in this case, tan inverse of natural log of x arctan times 1 over x dx. Then I think, so the same form here, this is the derivative of natural log of x. So we can use that substitution, but after applying the substitution, you will get something like this, arctan u du. Then we should integrate this one. Yeah. So for that, we need a different strategy, but I just want to mention this idea. Can't integrate this function right now because we can differentiate tan inverse. To integrate tan inverse, we use a special method that is actually integration by parts. But I think you got the idea about substitution. Right? Basically, we simplified this complex integral to a form like this. After that, we can use a different strategy. Here, I don't think we need a different strategy. We can use the substitution rule. Then you will get tan u du. Same idea. Then we can integrate this one very easily. That is sin u over cosine u. At this point, we can create the derivative of the denominator in the numerator. That's the idea. So we know that the derivative of cosine u is minus sine u. Hence, I'm going to put something like that. This I'm going to try something like this. Minus 1 times minus 1. That is plus 1, right? So we can put plus 1 whenever we want to, right? Because we can write 1 here. That's not a problem. Times sine u over cosine u. Because I need minus 1 sine u. So that's why I built minus 1 into minus 1. Then we can take this minus sign out. Then we built that. We built the derivative of cosine u in the numerator. Then I think we can easily integrate. Sometimes people write like this. The derivative of cosine u. After creating this form, we can write the answer straight away. That is minus 1 natural log of cosine u. I'll explain those concepts separately, but sometimes we should use these concepts because that's the idea behind the derivative of 1 over x as well. Because the derivative of x is 1, right? So that's why we write this. Right? That's why we integrate this function like this, natural log of x. Right? That's the idea. Then for the 8th problem, now slightly different, I should say that. But what do you think about that problem? Can we apply the same strategy here? For that, the inner function should be equal to natural log of x. Right? So whenever we have natural log of x as our inner function, we can use that substitution. But right now, what is the inner function? Okay, I would like to express that integral like this. Now, because 1 over x is the derivative of natural log of x, so I can use u equal natural log of x as my substitution. But what about that 4? Actually, how would you explain this entire function? Right? How would you build this function? Initially, x to natural log of x. Then you can't take the reciprocal of natural log of x. That is 1 over natural log of x. That's not the idea here. Can you understand? If you create 1 over natural log of x here, after that, how would you create 1 over 4 plus natural log of x from this function? Can't do that, I think. Right? Hence, the next function should be 4 plus natural log of x. That's very important. Identifying functions. Then we can take the reciprocal of this function, that is the outer function. So basically here we have 3 functions. Let me name. This is f, g, h. Maybe you can write functions f of x equals to natural log of x. G of natural log of x equals to 4 plus natural log of x. Hence, g of x equals to 4 plus x. Because this is the input for that function. This is the output. Right? And similarly, h of x, the outer function. Let me write like this. H of 4 plus natural log of x is 1 over 4 plus natural log of x. Hence, h of x is 1 over x. Because this entire thing acts like x. Right now, because that's the input. Right. Now, the question is, what's the inner function? So clearly, we have 2 inner functions. This part and this part. You can choose, because we agreed to select the inner function as our substitution. Now clearly we have 2 options. In fact, we have 3 options. Either you can use u equals f of x, natural log of x, or u equals to this function x to 4 plus natural log of x. That's a composite function. We sometimes write like this, but don't worry too much about that. F of g of x. So that is 4 plus natural log of x. Right? So the question is, what would you select? Natural log of x or 4 plus natural log? Doesn't really matter actually. But I think selecting 4 plus natural log of x is the better choice. Because that way, the denominator will reduce to u. But if you use u equals natural log of x, the new denominator is 4 plus u. I prefer u instead of u plus 4. Hence, I'm going to use this substitution. But you can use the other one as well. then the same idea. Right? Then convert everything to u. Prior to that, the derivative of 4 plus natural log of x is 1 over x. Hence, I can replace this part by this. If you're using natural log of x as your substitution, you can replace that part by the derivative of natural log of x. Doesn't really matter. Once again, we build that form. Then the substitution is u equal to 4 plus natural log of x. Then differentiate du over dx equals to the derivative of 4 is 0. The derivative of natural log of x is 1 over x. So basically, du equals to 1 over x dx. Right? Hence, this part, actually this entire part, we can replace by du, and this is 1 over u. So the integral now 1 over u du. Please use, when you are integrating, use this form. Don't need to use this form because we use that to identify the substitution. Then now this is very straightforward. It's like 1 over x dx, that is natural log of u, this one. U equals to 4 plus natural log of x plus c. That's the answer. Right, so identifying those functions quite important. And also, once again, writing this, the function inside the integral as a product is quite helpful. Then for the next problem, that exponential problem, this one, I think we can apply. Why can't we apply the same thought process for a different function? We should be able to. Let's see. Now let me express this one as a product. That's the fundamental. Then here, this exponential function is exponential x to the power of 3. Then the other function is x squared. Clearly, this is a composite function, this one. To build this function, how would you build that from x? Initially x to the power of 3, then the exponential function. Right? So this function, let's say f of x, that is x to the power of 3. This one, g of x to the power of 3 is exponential x to the power of 3. But g of x is exponential x. Right? Because that entire thing, we take that one as our variable, as our input. Hence, clearly, this is the inner function. So let's differentiate that to get a better understanding about the integrand, the function inside the integral. So I'm going to differentiate them. So the derivative of x to the power of 3. So why do I differentiate inner function? Why? What's the reason behind that? I always differentiate the inner function. Why? Because that's what we do in the chain rule. We initially differentiate the outer function, then the inner function. So, right, that's why I'm differentiating the inner function to find the original function, right? So this function is someone's derivative. We need that function. Right? Probably this function obtained by applying chain rule to a certain function. I need that function. So to get that function, I'm going to apply the reverse chain rule. Right? So that's why I try to create that form. Right? So x to the power of 3 is 3x squared. I think that's good. Because if you observe that integral, now x squared, here we have x squared, but I can easily create 3x squared there. Just need to multiply and divide by 3. We can always create constants. We can manipulate constants. 3x squared over 3. But 3 in the denominator, that we don't need that. I'm going to take that out. That's 1 over 3. X squared dx. Hence, that is basically this part, 3x squared. That is the derivative of the inner function. That is x to the power of 3. So I can use that. Once again, that form. Like now it's very obvious. Right? Please compare those forms that I built for all the functions. Then you will be able to identify that form. And also in questions, in upcoming questions, you can create that form. That way you can identify the substitution. Right? So clearly, x to the power of 3 is the should be that x to the power of 3 is the appropriate substitution. So u equal to x to the power of 3. Then you can integrate this very easy. Right? So u equals to x to the power of 3. Du equals to 3x squared dx. Then this is du, here u. So basically 1 over 3 u du, then integrate that. That's very easy. Then I think you will get u squared over 2, because the power rule, plus c, 1 over 6 x to the power of 3 to the power of 2 plus c. Right now, sorry. I think here, this is not correct. That's not correct. That's exponential u, because we replace x to the power of 3. 1 over 3 exponential u du. So that's not correct. But then that is exponential u again, because the antiderivative of exponential u. Then replace u by x to the power of 3. 1 over 3 exponential x to the power of 3 plus c. Right. Now, please differentiate this answer with respect to x to understand this. concept. Right? Now, definitely, we should use the chain rule. Don't worry about c. C is just a constant, so that's 0. 1/3. Here, now we can apply the chain rule. Right? I think you know those things. Fix x to the power of 3. That's the inner function. So we are differentiating basically exponential x function like that. Then the derivative of the inner function. That is x to the power of 3. Now, if you observe these two, this one and this part, I think you can understand the idea behind U substitution. Right? So we basically try to integrate this one. So that is, the answer should be that function, right? Okay. So we can use this idea for different functions. I'll explain those concepts in future sessions. Right? It's really important identifying these functions, particularly inner functions. Okay, thank you very much.